Hello, Chemistry 12. This is Mr. Chan. And today's lesson is talking about building electrochemical cells. And what this is actually a combination of the 3 or 4 lessons that you've done before this. So things like using the standard reduction potential table, talking about balancing half reactions, balancing redox reactions, and the quantitative aspects of electrochemical cells. So we're going to put that all together, and it'll help you explain why your cell phone battery works. Okay? So what I'm going to do is I'm going to share the screen. Last time I didn't share the screen, and it was completely blank. Okay, so what are electrochemical cells? Now, one thing you need to be aware of is that it all really, depending on which book you use, sometimes they don't call it electrochemical cells. Sometimes they call it galvanic or even voltaic cells. Okay. Now, regardless of the name, what it is that it is a chemical system where a spontaneous oxidation reduction reaction can occur to produce useful work. Now, the key thing is this. It is a spontaneous oxidation reduction. Spontaneous. Okay? Now, regardless of what the battery looks like, the general setup is exactly the same. So what you have is you have 2 half cells that are connected by a salt bridge. So in this diagram in your notes, what I have on the left is the oxidation half cell or oxidation reaction. And on the right-hand side, I have the reduction reaction. Okay? Now, each of these cells is made up of the metal electrode and its corresponding ion. So in this case, let's say if I have a zinc metal, I have a zinc solution that has zinc ions. Okay? Now, so you have a salt solution, okay? For the oxidation, you have a salt solution for the reduction, and those 2 solutions are connected by a salt bridge. Okay, I'll talk about what a salt bridge is. The electrodes are connected by a wire. So here, this is a wire. Now, in this particular diagram, you notice I have this V. That represents a voltmeter. But it's basically a general representation for anything that uses electricity. So I could even do this. Okay? Now, if you folks say this word out loud, my recommendation is you go to the washroom to get yourself cleaned up. Get it? Okay. All right. So the 2 half cells are connected by a salt bridge. Okay. Now, what is the salt bridge made of? The salt bridge, what it is basically used to balance the positive and negative ions in both half cells. And it usually consists of a strong electrolyte solution. Okay? So something like, sodium chloride or potassium nitrate, another name for this is called an ionic solution. This goes back to Chem 11. Okay? Ionic solutions. So solutions that have ions in it. Now, when you are using this, let me just check to make sure that this is all working. Hello, test, test. Okay, good. Now, what are the symbols that are used? Come on, come on, come on. There you go. Now, for an individual half cell, what it is that it's the electrode and its ion is separated by a single /. So right here. That represents a half cell. So the one that I highlighted tells me that it's a zinc with a zinc +2 ion half cell. Now, for an electrochemical cell, what I have is I have my 2 half cells that I have here. And what we have is we have this double line, which is here. Okay, so that represents these 2 half cells, the zinc, zinc 2 plus, and copper, copper 2 plus. They're connected in an electrochemical cell. Now, in some books, you'll see a diagram like this. All right. Now, some of you might say, well, Mr. Chan, where's the salt bridge? I don't see a salt bridge like what you've highlighted. Well, even though you don't see a salt bridge, this is considered an electrochemical cell as well. Why? Because in this case, you have your zinc and zinc solution. Here on the right-hand side, you have your copper and your copper solution. There's my 2 half cells. What happens is the electrodes, or the piece of metal, is connected by a wire, which is right here, and I'll just highlight that. The salt bridge is represented by this porous disc. This porous disc basically means that it allows ions through. And so what happens is this porous disc is a replacement of the salt bridge to allow ions to go through. Okay? All right. And the light bulb you see here, hopefully you can see it. What it is basically anything that uses electricity. All right. Now, you notice there's some diagrams here. You see that the zinc, there's this little thing here and electrons going. How are we supposed to figure that out? And this is where you take the lessons from the past 3 or 4 classes and we put it together. So what I'm going to do is I'm going to break this down and I'm going to show you how we get the information. So in this case, I'll give you the standard picture. So this will be my zinc, and this will be my copper. Here, I'll put that in blue. So this will be my zinc ion solution. And so I would use something like, I don't know, maybe zinc nitrate. Okay. Here would be copper 2 plus ions. And my solution, I don't know, I'll say copper 2 sulfate. Okay. Now, connecting the 2 solutions, remember, is my salt bridge. In this case, I might use, let's use sodium plus, chlorine minus 1. Okay. And then here, connecting the 2 electrodes is my wire. And I'll say, here's my Samsung Galaxy. I don't know, was it 10S or something? I don't know, whatever. All right. So what's going to happen when we put these 2 together? Well, the first thing we need to check, which one oxidizes or reduce. Okay. Okay, we take a look at which one oxidizes and which one reduces. Now, for us to figure that out, we have to use our standard reduction potential table. Okay, and hopefully all of you are familiar with this. So we look for, in this case, I'm going to look at copper. So I'm going to look for my copper solid, which is right up here. And I look at my zinc, which is down here. Okay, so here's my copper. Here's my zinc. Now, in this case, you notice that zinc is lower to the right, so zinc will tend to oxidize more. Okay, this is going back to how to use the standard reduction potential table. So here, under oxidation, I have my zinc solid goes to zinc plus 2 and 2 electrons. And for my reduction, by default, I will have my copper plus 2 ions plus 2 electrons to give you copper solid. So what I get is the overall reaction. I would have zinc solid plus copper 2 plus 2 ions gives you zinc plus 2 ions and copper solid. Ooh. Okay. So how would that look on this diagram up here? What happens is the zinc ions, the zinc solid, would start forming more ions. Here, the copper 2 plus ions will actually start to form, in this case, copper solid, because that's my product. All right? Now, so what happens is this. As the reaction proceeds, concentration of zinc plus ions increase. Okay? And the copper solid, okay, oopsie. Let's go back here. So zinc 2 plus ions decrease. The zinc solid mass decreases. Okay, why? Is because the solid is turning into ions. Conversely, what happens is the concentration of copper plus 2 ions decrease, but the copper mass increases because I'm making more copper solid. Okay? That is number one. Okay? Now, number two, the electron flow. Okay? Through the wire, from zinc to copper. Come on. Oh, my pen is out of ink again. I just changed the battery, so it should work. I wonder if this is the thing is slow. Okay. From zinc to copper. Okay. Okay. So what does that mean? So notice what we have up here is we have electrons being produced, electrons being used up. So what happens is the electrons will flow from the zinc because it's being oxidized through whatever is using it, and then comes down to copper. And I'm just going to change the color here so you can see it. So what you have is copper being filled with electrons, and that is what is attracting the copper 2 plus ions. So that's exactly what's happening if I stop sharing here. When you turn on your cell phone and you're checking whatever, okay, what's happening is that there's a spontaneous oxidation reduction reaction going on, and the electrons are flowing through your cell phone, in this case the screen, to allow you to turn on your cell phone. Okay? Now, go back to my screen sharing. Come on, screen sharing. Okay. Now, so that's what's happening right now. Now, what's happening with the salt bridge? So for 3, the ions in the salt bridge move to balance the charge. Or prevent polarization. Okay, now what do I mean by this? So if you take a look, notice in my zinc half cell, I'm starting to produce more zinc ions as what I had written down. So what happens is, since there's a buildup of zinc ions, what happens is the chlorine will flow over to sort of balance out all the extra positive charges of the zinc. Okay? Now, because the copper 2+ ions concentration decreases, you're going to get less and less positive charges in the copper half reaction. And so to neutralize that, sodium, if we have sodium here, will move over to sort of balance out the decrease in copper charge. Now, you might say, well, Mr. Chan, what happens, let's say if the salt bridge runs out? You have to remember, in the copper ion, in the copper solution, there's SO4 minus 2. And what will happen is that it will start to flow into the salt bridge. As the chlorine concentration goes down, the SO4 concentration will start flowing into the salt bridge to help neutralize the charge. And conversely, as the sodium ion concentration decreases in the salt bridge, the zinc has to flow in it as well. Okay? Something for you to be aware of. All right? Now, number 4. As the reaction proceeds, voltage will start to decrease until reaction reaches equilibrium, and that is when the voltage is equal to 0. So when your cell phone dies or when you run out of charge, it doesn't mean that there's no more chemicals in your battery. What it means is that the reaction that's going on in your battery has reached equilibrium. And this is why the voltage is decreased or goes to 0. And this is why when you charge your phone, what you're doing is you're actually reversing this reaction, driving it to the left to produce more reactants again. And this is why your phone is now charged. What's happening is you have lots of reactants. It's able to react again to produce products. And that process of producing products is what is called our battery voltage. Okay. The last thing, and then we'll call it a day, and then I'll show you a couple of things. Okay, number 5. The zinc half cell oxidized. It's called the anode. The copper half cell reduced, and this is called the cathode. So the species or the half cell that's undergoing reduction is called the cathode. The half cell that's undergoing oxidation is the anode. Easy way to remember it, O and A, the vowels go together, and R and C, the consonants go together. Okay, now that is the basis of how electrochemical cells work. So it doesn't matter if your electrochemical cell, let's see if I have it here. Yeah, okay. If you're taking a look at electrochemical cell, how one is set up in your cell phone is exactly the same as the basic setup as what's in these ones you use in your calculator or whatsoever. Okay,